In this video, I will demonstrate how to perform a z-test for the difference between two population means. We begin with the following example. A researcher for veterinarian studies claims that the average lifespan for domesticated dogs is greater than the average lifespan for domesticated cats. She collects random samples from both populations and computes the following sample data. Test her claim using alpha, also known as the level of significance of 0.05. For the domesticated dog, a sample of 35 dogs was collected. The average lifespan, 18.5 years. The population standard deviation, 3.5 years. For the domesticated cat, sample of 42 was collected. The average age is 13.2 years, or average lifespan. The population standard deviation is 6.5 years. Step 1 is we need to state the claim, determine H0 and H sub 1. So we have to assign variables to the two population parameters being analyzed. We use mu sub 1 for the mean lifespan of all domesticated dogs, mu sub 2 for the mean lifespan of all domesticated cats. Thus, we can write the claim as follows. Mu sub 1, the average age of domesticated dogs, or lifespan of domesticated dogs, is greater than the average lifespan of domesticated cats. That's our claim. Since it's greater than, it's an H sub 1 statement. H0 is always that the two means are equal. Since we are given the two population standard deviations, we know it's a z-test. We draw the normal distribution. H sub 1 has a greater than, so it's a right-tail test. And we also know that alpha is 0.05, so we can look up the critical value, which is the value that separates the shaded and unshaded regions in table F. It's a one-tail test. Alpha is 0.05, so we scroll all the way down to the very last value, which is 1.65. That's our z value. So the critical value is 1.65. Next, we have to compute the test point using this formula. Z is equal to the difference in the sample means minus the difference in the population means divided by the standard error, which is sigma 1 squared over n1 plus sigma 2 squared over n2 inside a square root. Keep in mind that mu sub 1 minus mu sub 2 is 0. So when I perform calculations, I basically leave out mu sub 1 minus mu sub 2 since it's 0. We have the difference in the two sample means, 18.5 minus 13.2, divided by the standard error, which is square root of 3.5 squared over 35 plus 6.5 squared over 42. This will give us a value of 4.55. Let me go ahead and work this out in the calculator. So in the numerator, I use parentheses for the calculator. Okay, there we go. Let me clear that real quick. And let me just see the value. So 18.5 minus 13.2, close the parentheses, divided by, now I use the square root function, and it's 3.5 squared over 35. So we have 3.5 squared divided by 35 plus 6.5 squared over 42. Let me just verify that real quick. Yes, that's correct. So the next step, hit enter, and we get our value, 4.55. 5.5. We make a decision regarding H naught. Remember, each test is to determine whether we reject or not reject H naught. The test point definitely falls in the critical region, so we reject H naught. We write our summary. Let's go back to the claim. We rejected H naught. The claim is H sub 1, so we can support the claim. That is a summary. There is enough evidence to support the claim. Thank you for watching the video.